Welcome to my presentation. I'm Shingo. First, let me introduce my team. Actually, my wife Mariko. We are married hackers based in Tokyo, Japan. We are making so many kinds of software and hardwares, including PCR at home, raising two kids, 4 years old and 1 year old. If you are watching this on live at my slot, 9 p.m. Pacific Daylight Time, it's almost lunchtime in Tokyo. They'll never leave us alone, so unfortunately, this presentation is pre-recorded at midnight one day before. But don't worry, I put my contact information at the last page of this slide, so that you can ask me any questions by email or Facebook Messenger later. We are staying at home with kids for almost 2 months, since March 28th. As you see here, Tokyo has only 3 cases today, and nursery school will be open from June. It was tough days for us, but thanks to the helps from other hackers worldwide, we are making open source COVID-19 detectors much faster than we have expected. In this presentation, I want to introduce what we made, what we are making, and how open source movement helped us. But first of all, let me point 2 important things. First, we don't use biosamples for development. Instead of real sample, we use custom oligo to evaluate our machines. Second, PCR is not a perfect tool to detect diseases. Sensitivity of COVID-19 PCR testing is said to be between 50 to 70%. So keep in mind that there's always a possibility of false positive and false negative. Well, these are machines. Everything are open and the GPL version 3 license. NinjaPCR was made years ago. Ninja Lamp was finished this month after a week of development. And currently, we are making Ninja qPCR. Honestly, we forgot why we named it Ninja, so no one knows right now. But maybe that's the most well-known Japanese word, isn't it? PCR, LAMP, and qPCR are all names of methods that can visualize specific DNA you are interested in. In these days, COVID-19, but that's just one example. By changing reagents, you can detect almost any kinds of DNA or RNA with this device. For example, 200 million people are infected by malaria, and 400,000 of them are killed every year. Malaria has its own DNA. Each year in the United States, 200,000 people require emergency medical care for allergic reactions to food like peanuts. Of course, peanuts has its own DNA. DNA is too small to see, and we need to make it visible. From criminal investigations to pecuniary tests, these tools are used worldwide. Let me describe differences between these methods. PCR, polymerase chain reaction, can be done by changing temperatures rapidly. In this graph, these are 3 stages in one cycle, almost in 5 minutes. We repeat this 30 to 40 cycles and get millions of copies that can be visualized after post-processes. LAMP, loop-mediated isothermal amplification, is latest technique. Shortly speaking, we don't need to change temperature but hold it for an hour. Very simple. Like glowing snowflake, fluorescent materials stick to the target part of DNA, and you'll be bright enough if target exists in sample. qPCR, quantitative PCR or real-time PCR, is just a PCR, but the copy is fluorescent and the machine checks its intensity every time. If it exceeds threshold after cycles, that means target exists in sample. PCR needs lots of post-processes, like electrophoresis and illuminator. As you see here, results is analog. LAMP is easy because of its fluorescence. qPCR too. The results can be acquired digitally. LAMP is really new method, so qPCR machine is mainly used at PCR testing. But let me detail NinjaPCR first. Wi-Fi is supported and you can use it with your phones. There are several kinds of open source PCR machines in the world, but Ninja PCR is quite unique because of its thermal simulation. Most of PCR machines use temperature of tube holder is equal to the temperature of the liquid inside the tubes, but actually it's not. This is the temperature graph of Ninja PCR. Red line is the result of our simulation, and blue one is actual temperature inside the tube. I measured it by sticking thermistor inside the liquid. You will find how precise it is. This thermal simulation is imported into NinjaLab. It's very simple and the purchase price is only $50. You can make your own NinjaLab by connecting Arduino, few registers, MOSFET, heater to tube holder. We shared how to calibrate with any heaters and tube holders. It's actually manufactured in Indonesia by my friend Akbar. He's also a hacker and biologist. Just after he shared a paper about how to detect the COVID-19 with lab method at the end of April, I started making NinjaLab, and just a week later, it's done. I shipped only core parts to him, and he 3D printed these lovely pink enclosures. NinjaLab is really easy to extend, and he added status LED. Alman in Columbia University, New York, made his own lab machine forked from NinjaLab, adding LCD display. I heard that he successfully detected positive sample with it. By COVID-19, so many papers are published by researchers, but not all of them had access to hardware required. Open source hardware is a key to catching up to your urgent needs. If you are a member of local hackerspaces, you may already help healthcare workers by making PPE like face guards. But maybe we, makers, can do something more. Who needs affordable lamp or qPCR machines? They have great potential to solve so many problems worldwide. I said qPCR machine is mainly used for PCR testing, but typically commercial qPCR machine costs 20,000 to 200,000 US dollars. Look at the long line at the test site. Sometimes they have to wait 5 or more days to get results. If healthcare workers can use enough machines, required days will be shortened drastically. Look at the Akbas in Nesia. Almost 300 million people live in more than 10,000 islands. Total confirmed cases of COVID-19 exceeded 20,000, and the situation is getting worse there. Imagine if every small hospital in such islands has their own qPCR machines. Imagine how many lives can be saved. What's in need is not a single $200,000 machine in capital city, but $50 machines in 4,000 islands. Not only islands, closed, separated, or isolated areas can be found everywhere in the world. Cruise ships, refugee camps. Yes, this is refugee camp in Jordan. Imagine if all such places had their own qPCR machine. After COVID-19, we need to change a lot. But if there's only pricey machines in market, some extraordinary ideas will be rejected easily due to its cost. For example, how about giving one qPCR machine to all PCR testing license holders? In case of Japan, it takes at least 3 years to acquire a license to become a healthcare worker who is allowed to pick samples from patients for diagnosis. Establishment of new medical license for test site workers that can be acquired in shorter term is another example of preparations we can do for second wave. PCR is an essential method not only for diagnosis but also for citizen science and education. If we can use affordable qPCR machines at home, it changes our daily lives. Small kids with food allergy can check their foods by themselves with their phones. Most of us, including me, has never had DNA experiments in school because we do not have PCR machine in classroom. Farmers, livestock farmers, fishermen, they can check the environment by themselves. And of course, we, the makers, we can make our future by ourselves. So let me introduce our current project, Ninja PCR. Technically, it's really simple. Input and sense light while changing temperature with heater and cooler. There's already one example of open source qPCR named Chai Open qPCR, but it costs almost 4,500 US dollars. I really respect this product, but it's still expensive for me. So, target purchase price of Ninja qPCR is 300 US dollar. I'm pretty sure we can do that. For example, Chai use big bone and 64 corpers, the worth $187, while Ninja qPCR use Raspberry Pi and 54 corpers, worth $96, almost half. We started Ninja qPCR project from March, Ninja Lamp from April. Since that, so many people joined our project. BioClub, Biohackerspace in Tokyo hosted an event for networking. Individuals helped us with their knowledges and donations. Company in China helped us to make tube holder at lowest price. That could never be happened if Ninja qPCR is closed source project. That's exactly the power of open source movement. I and Mariko are both software engineers. We managed to learn how to make hardware, but no background about the biology at all. Thanks to all people in this map, Ninja qPCR project goes much faster than we have expected first. We're staying at home for 2 months, but we felt that we are connected to the world. Let me share current progresses. We tested optical filter with Lego, baby food bottle, and bath salt with fluorescence. It looks like toy, but its wavelength is exactly the same to qPCR reagents. So we are so serious. Circuit diagram is completed and the first tube holder will be made in Shenzhen, China within a week. Mariko is writing embedded source with Raspberry Pi and Node.js that communicates with web user interface written by Valerio in Detroit. We still need more help, especially we need to talk with commercial qPCR users to improve our user interface, making hardware is heard so donations are always welcomed. Thank you for listening. You can get this slide from this URL to check the links I put in. And here's also my contact information. Feel free to ask any questions to me. Happy hacking!